So today we have to learn something very new, and that is really will help us to understand and to evaluate the stability of the system. And I have something, I think the book has given good examples, but it has not clearly told that how to do it. So I have some photocopies which I'll distribute in a minute. But before I go, I just want to tell you a very simple thing, that if we have, for example, the transfer function, we have the numerator and the denominator. This is what we were doing. And we know that if we want to find out and want to investigate the stability of the system, then there were only two simple things to do. Number one, to define your characteristic equation. And the characteristic equation was that you actually put the denominator equal to 0. So you have characteristic equation where you will put ds equals to 0. Okay? And when you put ds is equal to 0, you actually look at its roots. And these roots, the nature of these roots will tell you whether the system is stable or not, because they can be imaginary. You can actually plot those points on a plane and can see whether the roots lie on the left-hand side, on the right-hand side, or they are on the imaginary axis, and so on. So if that is the case, then it simply means that for us really to understand this whole thing depends on the roots and to understand the nature of roots. But as you know that if the characteristic equation is simply a quadratic equation, then there is no problem. You can solve, or you can factorize it. But let's see what will happen if your characteristic equation becomes s power 5 plus s power 4 plus 3s power cube plus 9s square plus 16s plus 10 equal to 0. Can you find out the roots to understand what is happening to the stability of the system? Right? So this is something we have to learn, that what to do in cases when you have a long equation, the characteristic equation is really long, big, and you are unable to really solve and find out the roots of this equation. So one criteria which was given by these guys, which are called Routh-Hurwitz criteria, that is very important. What they say is, they say you play basically, you just play with their coefficients. Forget about everything and you play with their coefficients and see how these coefficients can be written. So you start with, for example, S5. This is the highest. Then you go for S4. Then you go for S3. Then S2. Then S1. And of course, then you have S0. So you write the coefficients here. Now, how you write the coefficients? Remember that we can actually use some formulas to find out these coefficients, and that's exactly we are going to do. We will use the formula to find out the coefficient here, 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 5 of them, and then we go to, from this information we go to S4, then we go to S3, then we go to S2 and S1 and S0. How we will do that is given here. So there is a general formula here for these coefficients. So you go and read that. So read this please, and then solve this one please. So please solve it in the class. is 5. I can upload this. So the first one is, so you have to go and look at the values.
Are we reading 6.5?
So you start with, you have to find out coefficient an, then you have to find out coefficient an minus 2, then an minus 4, and you go until you get 0. The next one actually goes for an minus 1, then you will get an minus 3, an minus 5, and you go to 0. The next one will be b1. So this is for this is for this will be b1. Then you will have b2, b3, and 0. For S2, you will have, C1, C2, C3, and 0. So let's say that our maximum power was n. This power is n minus 1. This power is n minus 2. This power is n minus 3. And you continue until you get Si, S1, and S0. And these will be, the last one will be, just say, in the book it says I and J, and the rest of them are 0. So you have to find out the coefficients. Now, B1 and B2 are given. So the first thing you have to do is to find out basically your values. So the first one will be, I will write it with the red marker so you can see it. What will be the first line? What is our n? Our n is in this equation. What is our n? Huh? 5. So n is 5. So this will be 5. So S5 will be, what is an? What is an? What is the coefficient? What is the coefficient of?
1.
No, plus 1. The sign is very important.
Okay.
So the sign will decide. So we have plus 1. What is an minus 2? An minus 2. Plus 3. What is an minus